So in part 1, we started talking about conceptually what a mole was. Let's talk about how we would actually do math with this to make it quantitative, okay? So we said that a mole was a way for us to count atoms, but we can't actually physically count them, so they weigh them out. And in order to weigh them out, we use this term called molar mass. So remember, anytime you're talking about mass, anytime you see the word grams, it's important that you remember that we're always looking at the periodic table. So the way that we're going to be setting up these problems, no matter what unit we're looking for, is always going to be the same format. Okay, so problem 1 says we're calculating the number of moles of cobalt in 9.75 grams of cobalt. For any problem, we're always going to start with the number given. Okay, so I'm going to write the number given in the problem. I'm going to keep track of my units. This will be especially important as we start getting into problems that are 2 or 3 steps, okay? So here's what I'm going to do. I'm going to draw a line or a time sign and a line, okay? Whatever units I start with, I'm trying to make go away. And the way I make them go away is by dividing by them. So I put those on the bottom. Whatever unit I'm changing to, I'm always going to put on the top. Now I know that 1 mole of cobalt is always equal to the molar mass. And I know that I find my molar mass by looking on the periodic table. So I'm going to find cobalt on my periodic table. The molar mass is how much 1 mole weighs. So this says 58.933. I'm not going to leave this exactly as it is. I'm going to make my life a lot easier. So I'm going to make 58.9 59. So 59 grams of cobalt is equal to 1 mole. Now when I enter this into my calculator, okay, any number that's on top of the line, I'm going to multiply by. Any number that's on the bottom of the line, I'm going to divide by. So I'm going to take 9.75 times 1, and then I'm going to take that answer divided by 59. So when I enter this in my calculator, I could do 9.75. Now any number times 1 is itself, so I'm just going to do divided by 59, and I get 0.165 moles of cobalt. Now the reason that it's moles of cobalt, grams on top, grams on bottom, they cancel out, I'm left with moles. Now the way that we abbreviate moles in chemistry is MOL. I know it's not much of an abbreviation, but you can either write it like that or like that. It's the exact same thing. Okay, pause this video and take a second to try to solve number 2. So what we should have had in number 2 is we should have started with the number given, 32.3 grams of sodium. I'm going to draw my time sign and my line. Because I'm starting with grams of sodium, I need to write that on the bottom of the line. Whatever unit I'm changing to goes on top. I'm changing to moles, of sodium. Okay. Now I know that 1 mole of sodium is always equal to the number from the periodic table. I found sodium on the periodic table, 22.990. I'm going to round that to 23. Numbers on top I multiply, numbers on bottom I divide. So 32.3 times 1, any number times itself is always the same. So 32.3 divided by 23, I should have gotten 1.40 moles of sodium. Take a second and work through problem 3. Pause this video now. Now the second section, we're still using molar mass. So we're still looking for grams, and we're still going to be finding that on the periodic table. Okay? What's different is this time I'm changing moles to grams. So just like before, I always start with my number given. I've got 2.00 moles of iron. Just like before, I draw my time sign and my line. Because I'm starting with moles here, and I want them to go away, whatever I start with has to go on the bottom of the line. Whatever number I'm changing to has to go on the top. Now in this case, anytime you see grams, grams is from the periodic table. So I find iron on the periodic table, 55.93. 55.9, let's make that 56. And I know that the number from the periodic table is always equal to 1 mole. Now, exactly like last time, numbers on top I multiply, numbers on bottom I divide. So when I enter this into my calculator, I'm taking 2 times 56. Now, any number divided by 1 stays the same, so I'm just going to ignore this on the bottom. And I get 112 grams of iron. Remember, moles on top, moles on bottom, they cancel out. I'm left with grams. Pause this video now. Try number 5. Hopefully, what we should have done in number 5 is start with the given number, draw my time sign and my line. Because I'm starting with moles of nickel, those need to go on the bottom to cancel out. The problem tells me I'm changing to grams. I know that anytime I'm looking for grams, I need to look at the periodic table. Nickel weighs 58.69. I'm just going to make that 59. And I know that the number from the periodic table is always equal to 1 mole. So when I plug this into my calculator, numbers on top I multiply, numbers on bottom I divide. So 0.52 times 59. I should have gotten 30.68 grams of nickel. Okay. Pause this video. try number 6 and number 7. Now we said that the mole was actually allowing us to count atoms. So what if we were asked for those specific number of atoms? Okay. Now they use this term that I used in the last video. A dozen is 12. Avogadro's number is 6.02 times 10 to the 23rd. That's what we call a mole. Okay, so if I say Avogadro's number, same thing as 1 mole, still 6.02 times 10 to the 23rd. So just like every other problem, I'm always starting with the number given. I'm told I have 0.29 moles of sulfur. I draw my times sign, I draw my line. Because I'm starting with moles, I want moles to go away, so they go on the bottom. I'm changing to grams. Nope, sorry. If I read the problem, I'm changing to atoms of sulfur. Okay. Now I'm told that 1 mole is equal to 6.02 times 10 to the 23rd atoms of S. Okay. Now there are 2 ways that I can do this. If I have a scientific calculator and I'm comfortable with scientific calculators, I can put this in exactly as it's written. If I don't have a scientific calculator, or I'm just trying to use my phone, here's what I'm going to do. I'm going to take 0.29, whoops, sorry, and I'm going to multiply it by 6.02. I get 1.75. But that's not all of it. I know I need to take that number and multiply that by 10 to the 23rd. This 10 to the 23rd is the same thing as saying that I had 17500000000 for 21 zeros. So it's a huge number. So I cannot forget this. That's like somebody owing you $1.75 billion and giving you $1.75. You're not good, okay? Do not forget the zeros, okay? So I've got 1.75 times 10 to the 23rd. My moles canceled out. I'm left with atoms, okay? Take a second and try number 9. So if you paused the video and tried number 9, hopefully you got something that looked like this. 2.8 moles of aluminum. Because I started with moles, I wanted those to cancel out. Those went on the bottom. I'm changing to atoms. So atoms goes on top. The number for atoms is always 6.02 times 10 to the 23rd. Now on the front, our number for grams changed depending on the element. Different atoms have different sizes. It was like that bowling ball versus baseball example. Because they have different sizes, they have different weights. But anytime I use the word mole, it's always 6.02 times 10 to the 23rd, okay? So if I plug this into my calculator, I would have taken 2.8 times 6.02. which tells me 16.86. I don't forget times 10 to the 23rd, and these will be atoms of aluminum. Now, if you had a scientific calculator, if you plug this in exactly the way this was written on the scientific calculator, it would have told you this number and this number are exactly the same. This is true scientific notation. However, we're not going to take off points for this. This tells me you have a scientific calculator, but this tells me you still understand the concept. Take a second, pause, try number 10. So what if we need a little bit more information? Problems 11, 12, and 13 are asking for multiple steps. So they tell me that I've got 25.1 grams of iron. I want to find out how many atoms I have. Okay? So here's the way this works. Because I'm starting with grams, I'm going to find grams on the periodic table. Iron weighs 55.9. Let's make him 56. Okay. This time, I'm changing to atoms. If we remember, what number goes by atoms? 6.02 times 10 to the 23rd, Avogadro's number. Now, when I enter this into my calculator, it's exactly like I did before. Numbers on top, I multiply. Numbers on bottom, I divide. Again, if you've got a scientific calculator, great, but here's how I would enter this into my calculator. I'm taking 25.1 times 6.02. I'm taking that answer, dividing it by 56. So I get 2.69. I cannot forget about this, times 10 to the 23rd. My grams canceled out. I'm left with atoms. Okay? So it doesn't matter what units we're looking for. You always start with the number given to you in the problem. Whatever units were given to you in the problem are always going to go on your denominator. Whatever units you're changing to always go on top. Grams we find on the periodic table. Moles, well, they're always just one right now. And then Avogadro's number is for atoms.